All right, here's number 43. Going on until I don't have any more room. Let's go. Here's a rectangular decagon, and the area is 24.3 square meters. Determine the length of each side. Right, so decagon looks like this. Okay, a regular decagon, that means that each one of these is the same length. Okay, so you need, if for any polygon, any regular polygon, this one's a decagon, the area means the length of each side, the number of sides in the epitheme, right, divided by 2. So length of each side is pretty obvious, right, is this, the length of each one of these, right, and then the number of sides, that's pretty obvious, but what is this, the epitheme? Well, you got to take from the center point here, right, and then it's this length right there. It's kind of like a radius, right, a little bit like a radius here. Okay, so if I were to figure out what that is, right, I kind of have to just go from here. Let me kind of zoom in on it. Go from here to make it zoom in a little bit more too. Okay, so I'm gonna take this angle here. This is my line. Okay, and this here, this here, and this. Oh, that's fine. And this here makes an isosceles trapezoid, or an isosceles triangle. And in fact, if I go all the way this way, like with it, these are vertical angles like that. Oh man, I must hit a bump or something. And this here makes vertical angles. Okay, these make vertical angles. Right, and I know that each one of these angles here, this angle, these angles all here have to add up to 36 degrees. Okay, this angle in here and this angle, these angles here are also going to be equal to 36 degrees. Right, because if I go 360 divided by 10, each one of these angles is going to be 360 degrees, so it's going to be 30 equals 36. So this angle here and this angle here are going to be 36 degrees. Okay? So, this whole thing here is 24.3 meters. Okay? So let me put in what I know into my equation. Okay, I know that. Well, let me solve for my length of the sides. All right, so my 24.3 equals my side lengths. Erase that real quick. Side length times my number of sides times my epithem, A-P-O-T-H-E-M. It's a line perpendicular to the height of the center, so it's this guy right here. Okay, divided by 2. Okay, so this line is going to split my line segments, each line space into 2. So if it bisects, it's this. Oh, you can't see what I'm doing. All right, so if it bisects, if my epitheme bisects my side, it means that this and this are 2. Okay, so make a bigger triangle what I got going on, right? So effectively what I have going on here is I have an isosceles triangle, with an epithem I'm not even sure if I'm pronouncing that right. Probably not. I'll get some comments from real math teachers that will tell me I'm pronouncing it right or wrong. And this angle here, this whole angle here is 36 degrees. Okay, if that's the case, then each one of these is going to be 18 degrees. 18 degrees. And I'm trying to figure out LS. All right, so that's what I know so far. Okay, that's what I know so far. So, looking at this right triangle here, and with the 18 degrees, this length would be LS divided by 2, maybe half of LS. All right, so if this is theta, and I'm trying to find, this is LS divided by 2, I'm gonna use blue, I'm gonna use this green here, just to focus on this. Let me highlight a triangle, green, let me find a green highlight. So I'm focusing on this triangle here, this green triangle, breaking it down. Okay, so this is this blown up and flipped over. Okay, so I have this piece of this decagon blown up and flipped over here. And this is L over 2. And I'm trying to find this line segment length, because that's the only thing that I don't know of my equation. Because I know this is 10. This is 10. And this is 24.3. And I'm trying to solve for this. I'm trying to solve for, so I need to figure out the length of this. Okay. Once I figure out this, I just multiply it by 2 and I'll find that. Okay, so I know that this is going to be the opposite, and this is going to be the adjacent of this angle. Okay. So I'm going to be using the tangent of theta. And the tangent of 36 to be precise, equals, is going to be the opposite over the adjacent here. In this case, it's going to be the opposite, which is LS divided by 2 divided by my Pythagorean, which is going to be A. Let's say it's AP. Correction there, it's actually a tangent of 18. All right, and I'm going to go ahead and change this to a decimal so it's not, doesn't look as sloppy here. So it's a tangent of 18, not 36. So this is going to be 0.5 of my of LS. Okay. All right. All right. So 0.5 opposite. That's half of LS. That makes sense. Is going to be divided by my adjacent, which is AP, equals the tangent of theta. Okay, so I set up a relationship. That means that, so I can figure out the tangent of 18, and I know that it's, the relationship is that. So let me go ahead and solve this in relationship to AP, this line segment length. Oops. Okay, so AP equals 0.5, my line segment length, divided by the tangent of 18. All right, so let's see how that works out. I'm gonna go take 0.5 divided by 18 tangent equals, so my AP is 1.54 times the length of my S there, my length of my line segment. Okay, so now I can take this, and instead of using this here, I can take and drop this into here, right? And get rid of this LS, this question mark, and do the LS. Right, and I'm gonna do, it's gonna be LS times, it's gonna be, and I'm gonna replace this with 1.54 LS. Okay, so now I can multiply everything on the top here. It's going to be 4.3 equals LS times LS times 1.54 times 10 divided by 3. So what does that give us? All right, so we get 1.54 times 10 equals, divided by 2 equals 7.7 equals 7.7 equals 7.7 LS squared. Oh, that's right. So it's LS squared. Do that one more time. 1.54 times 10 equals, divided by 2. Yep, 7.7 LS squared equals 24.3. All right, now we're getting somewhere. All right, so now I can take 24.3 divided by 7.7. So 24.3 divided by 7.7, and that gives us 3.15. So 3.15 equals LS squared. So now I got to take the square root of that. So therefore, LS equals 1.78. 1.77. We'll do 1.77 equals 1.77. So there is that one. Okay. A little bit of substitution and some trigonometry. That was a good one. All right. Let's move on to number 44. Okay, we have a swimming pool filled with water, has a diameter of 10 feet. So it's a cylindrical swimming pool. It's filled with water, has a diameter of 10 feet, so the radius equals 5 feet. Okay, so let's kind of draw what we got going on. It doesn't need to be dotted like that. Okay, and this diameter is, this radius is 5 feet, and a height of 4 feet. Height of 4 feet. And water weighs 62 pounds, 62.4 pounds per foot cubed. Okay, what is the total weight of the water and of the full tank? I guess this is the tank, assuming that this is full to the brim. Okay, all right, so the volume of the tank which is, I guess this is a tank, equals the area times the height. Area of the base times the height, right? Which is going to be the circle, pi r squared, times the height. Okay, so this circle here, this circle right here, is our pi r squared, right? And our height is this green part right here is the height. Okay, this is our area, and this is our linear height. So this is going to be in feet squared times height. It's going to give us feet cubed. All right, so this is going to be equal to the blue pen. Okay, this is going to be equal to the area of base is 5 pi. This is 5 feet squared times pi times the height times 4 feet. Okay, so that all comes out to 5 squared times 4 equals 100 pi squared. Multiply that by pi. 314 equals 314.22 cubic foot. Okay, and it gives us 602 pounds per cubic foot. We need the answer, the nearest pound. So we have 314.2 cubic feet per pound, cubic feet, and we have pounds need to be on top, so 62.4 pounds per cubic foot. I'll multiply that by 62.4, and our total weight is going to be 19,603.5 pounds total. All right, there are 3 pyramids in Giza. The largest, the Great Pyramid. All right, who cares about the first part? Don't care about this. The largest has an approximately square base. Okay, it's a square base with the side lengths of 230 meters. Okay, so we have a square base pyramid. Try to draw that. Square base pyramid. And it would look something, man, why can't I draw pyramids good? Look something like that. Oh, they already got one for me. Look at that. I don't know why I didn't see that. All right. And the lengths of which are, with the lengths averaging 230 meters each. 230 this way, and then 230 this way. Okay, the lateral surface area of this many square meters. That means the total surface area, not the base, is this much. What's the height? Okay, so they gave us the hypotenuse. They gave us this. We can figure out the slant lengths and stuff like that. And so let's stand one of these up. Okay, and figure out what's going on here. All right, so the area for each one of these. So one of these areas here, just one, they're all the same. Okay, just one area, one triangle area is going to be equal to 85,836. Right? These are all the same, right? Because they're going to be all of the same height, and they're all the same width, right? They're all the same area. It's going to be divided by 4, right? Let's make that A bigger. The area of all of those triangles. So that's going to be equal to, let's see, 85,836 divided by 4, 21,459 meters squared. Almost run off the page there, right? So equals 21,459 meters squared. That's the area that I'm dealing with. That's my horizontal, that's my slant area. Okay, so if I stand up one of these triangles, do it like this, right? All right, then I look at it sideways, like this, okay? This here is from the slant height. That's this area that that's from that area there. This is 230, right? And this that I'm looking at right here, either way that I look at it, it's going to be half of 230. 230 divided by 2 is 115. So this is 115. 115. So it's like in the middle here. Maybe I draw it like with a little bit more pronounced, maybe the screen here. So I'll start in the middle, go up, I go out, and that's like the middle cross section kind of. Okay, so that's 115. All right, so the area of this whole thing here is the base of this times the slant height. Okay, I'm talking about the slant height. So this area here was the base. This thing here was the base times the height. I know the base here was 230. I know the area, and I know the area was 21. Area was 21,459. So I can figure out the slant height, right? So divided by 2, right? So the area equals the base times the height divided by 2. So if I'm trying to figure out, this is the slant height. So the slant height is going to be equal to 2 times the area, right? Multiply both times 2, right? Divided by the base. That's the math. That's the slant height. That's the slant height. It's going to be equal to, oh man, all right, 2 times 21459 meters squared. Okay, then divided by 230 meters. All right, so the meters will cancel out, and all of you left with meters. Meters squared divided by meters will be meters. So that works. All right, so 2 times 21,459 divided by 230 equals 186. My slant height is 186.6, which is the hypotenuse, 186.6 of this. All right, so if I want to find the height, right, my height is a leg. That's going to be the square root of my hypotenuse, 186.6 squared minus 115 squared, which is this leg, and it's going to be equal to that. So my hypotenuse equals that squared minus 115 squared equals, let's see, 186.6 squared minus 115 squared equals, take the square root, and it's 146.9. 146.9 Okay. And that's, well, 9.5 is what they rounded to on the key. Let's say to round it to the nearest thousandths. No, it doesn't. So I guess that's that. Okay, moving on to 46. Okay. Which location has the smaller population density? All right, so we're looking at population densities. Remember, population densities are number of, what do I got? I'm looking at population densities. It's just whatever. It's stuff over one unit of area. Okay. All right. So population is just people. Okay. So this is going to be 4ln, 4 natural log. Looks like they didn't correct that. All right, so there's going to be siesta key, and it's going to be 13,702 over 5,000. My population of Siesta Key was, oh man, they got it all messed up. So, Siesta Key. It was Siesta Key. Destin, Florida. Smaller population density. Okay. So I need to get my pink values on one side and my other values on the other side. So people first. 5,573 over 3.475. Go to my orange values. 1,307.02 over 8.545. Do the maths. This is people over square miles. This is people over square miles. Units matter. Make sure you put them in there. So we got 5,573 divided by 3.475, and that is approximately 1604 persons per square mile. This is 13,702 divided by 8.545, which is approximately 1604. They're the same. 1604 people per square mile. So let's see. Oh, I guess they're really close. I gotta round less. So 5,573 divided by 3.475. 1603. Let's round closer. So this is 1603.741 people per mile squared. This is 13,702 divided by 8.545, which is this is 1603.510. So this is smaller. So the 1603, samesies. 5.510 is smaller than 0.741. So this is smaller. So that's your answer. Destin is smaller. All right. Let's do number 47. Filling cylinder silos. The top of the cone is filled. However, the silo's bottom cones were just 3 different silos filled. Top and silos are congruent. How much more grain could silo 1 hold than silo 2? Answers are in percentages. Okay. So let's move on to percentages here. Okay, so part A we're looking at. I'm presuming this is silo 1. This is silo 2. Oh, they're labeled in silo 3. They are labeled there. 1, 2, and 3. And everything is congruent. This is a proportionality question. All right. So, what is the proportion between 3 and 1? Okay. So, how much more grain? 3 to 1. So 2.4, 1, 3 and 1, 1.5, 2.4. Oh, this has this little extra little thing here. Okay. All right. So we got to look at the volumes. So the volume of, let's just calculate all the volumes. All right, the volume of 1.5, they're going to be the same. And then these are all the same, and these are all the same, right? So so I can define 3 different volumes. There's volume pink, which is that. There's volume orange, which is one of these here. It's like a cone, right? That's volume. These are volume oranges. And then there's volume green. If I can find the green. Green. Oh, looks like I'm almost coming out of. Might have to cut this one to the next one. I'll do volume blue. Sure, why not? Volume blue, which is this one. So here is how you do this one, okay? I prepared it for the next video for you. Think about how you do it, and then move on from there.